Hi friends, in this video we are going to discuss about the comparison between the open loop and closed loop control systems, and these comparisons are very important. And see, first we are going to discuss about the open loop control system points, and after that we are going to comparing all these points, we are going to comparing with the closed loop control system. Okay, now first thing is coming to the open loop control system important points. Okay, now point number 1, in this system the controlled action is free from the output. Control action is free from output. It means what? Output is not going to affecting upon input. Okay, that is point number 1. Now point number 2 is this control system is also called a non-feedback control system. Non-feedback means in case of closed loop control system, for example, this is input and this is output. From output to input, we are having one feedback path. So in case of this open loop control system, we do not have feedback path. So that's why we are calling as non-feedback control system. And point number 3, the components of this system include a controlled process and the controller. So in case of open loop control system, this particular system include controlled process and also controller. Both are placed in the block diagram or system of a open loop control system. And coming to the fourth point, that is the construction of this system is very simple compared to what? Closed loop control system. Because in case of closed loop control system, we are having the feedback path, so that whenever we are going to comparing or constructing the open loop control system block diagram, so this is somewhat simple compared to closed loop control system. And the next point is the consistency is non-reliable. So in case of open loop control system, consistency is not reliable, but in case of closed loop control system, the consistency is completely reliable. And the next point is the accuracy of this system mainly depends on the calibration. So whenever we are going to getting the system response, so whether the system output is whether accuracy or not. So in order to get this accuracy of this system, so this accuracy mainly depends on the calibration part. And coming to the next point, that is the system of these systems, okay, the stability of these systems are stable, because for example this is the system having a output and input. It means, for example, if we are getting output as, for example, 100 volts, we are getting output, means this 100 volts is the accurate output. It means this output is not going to affecting on input, means there is no changes occur in the output. So that is the reason why the stability of these systems are stable, because the output is not going to affecting on input. That is the reason why there is a stability in the output. But in case of closed loop control system, output is always varies and output is always affecting on input to get the accurate output. So that is the reason stability is not good in the closed loop control system, and stability is always good in the open loop control system. And the next point is the optimization in this system is not possible. So optimization is not possible in case of open loop control system. And the another point is the response is fast. It means how much voltage you are applying for the system, some amount of, including some amount of losses, you are getting some output, and this response is always fast compared to the closed loop control system. That's why the response is fast. Next, the calibration of this system is difficult. The calibration of this system is very difficult compared to the closed loop system. And coming to the next point, that is the disturbance of this system will be affected. The disturbance of this system definitely affected, but this is not possible in case of closed loop control system. These systems are non-linear. These systems are completely non-linear. That's why we are calling as every open loop control systems are always non-linear. Okay, and here the best example of the open loop systems are automatic washing machine, traffic light, TV remote, immersion rod, etc. So all these are the some examples of open loop control systems. Okay, so all these points are related to the open loop control system. Now we are going to comparing all these points with respect to the closed loop control system. Now see, coming to the closed loop control system points. Now see, in this case, first point is, in this system the output mainly depends on the controlled act of the system. Okay, controlled act means we know that, for example, this is a system having output and input. For example, this is input and this is output. This output is always sent to the input through a feedback path. So that is the reason why output mainly depends on the controlled act of the system. And the point number 2 is, this type of control system is also called as feedback control system. Why we are calling as feedback means, in case of closed loop control system, we are having the feedback path. That's why we are also called as feedback control system. And the point number 3, that is, the components of this kind of system include an amplifier, controlled process, and also controller, and including in that we are having feedback path also. It means amplifier is there, controlled process is there, controller is there, and feedback path are there. So because of all these components included in the control system block diagram, that is the reason why the construction of this control system is very, very complex compared to the open loop control system. That's why the construction of this system is complex. Now the consistency is reliable. So whenever we are going to operate in this closed loop control system, there is a consistency in the operation. That's why the consistency is reliable. And the next point is, these are accurate due to feedback. It means what? For example, same, if this is the, for example, this is the system having output and input. For example, what we are doing, for the simplicity purpose, just I am considering that we are applying some 100 volts as an input voltage, but instead of getting 100 volts at the output, we are getting 90 volts. It means 10 volts is the error, and this output is going to comparing with the input, and this input and output is going to compared by the comparator, or we can also call it as error detector, and that particular 10 voltage is, this particular 10 voltage is reduced to get the value of accurate output 100 volts. That is the reason why these closed loop control systems are very accurate due to what? Feedback system. Next point is, the stability of these systems are less stable, because the system is always changes with respect to what? Always changes. We can also call it as what? Whatever the output we are getting in the closed loop control system, if that output is not accurate, then what happened? This output is comparing with the input. It means what? There is a changes in the system. That's why these closed loop systems are not stable systems. Okay. Next, the optimization in this system is possible. Optimization is possible in case of closed loop control system. The response is very slow, because in order to get 100 volts, so for example, instead of getting 100 volts, we are getting 80 volts at the output. In order to get 100 volts, we require some time. That is the reason why the response is slow. Next, the calibration of this system is easy. The calibration part is what? Easy in case of closed loop control system. The disturbance of this system will not be affected. Next, these systems are linear systems. And the examples of this kind of control systems are always used in control systems for temperature and pressure, speed, toaster, and refrigerator. It means what? With the help of the control system, we are going to manufacturing some applications, like control systems are always used for what? So temperature concept, pressure concept, speed concept, toaster concept, and refrigerator. Like this, there are so many appliances are depends on the operation of closed loop control system concept. Okay, so these are the differences between the open loop and closed loop control system concept. So thank you so much for watching, and please do subscribe my channel for more updates. Thank you.